So I gave you some problem. I think it was number 7 on the do now. That was asking you to divide two numbers without the use of a calculator using long division, right?
I figured that out.
Do y'all remember long division?
Yes.
Kind of?
Yes.
Okay, good.
Very well. I've done it.
So my question to you, and even though this seems unrelated, it very, very, very much is not. So I'm going to use long division to take care of this, okay? And I need you to remember the steps to divide. I will spare you the song that I used to sing to my son because he hated it and I hated it. Divide, multiply. Oh, man. Well, at least you know that. That means you did it. Good job. The answer is not important. The process is what I want to show you. So we're going to divide, we're going to multiply, we're going to subtract, and then we're going to bring things down. And that is the important thing that needs to be understood today. So let's get started. So what I'm going to do is I'm going to try to divide 2 into 5. It will go twice. Then I multiply 2 times 2 and place it here. You're going to be real upset if you don't remember, and then I do it with polynomials. Yeah.
I remember dividing I got so much.
So 5 minus 4. Now we're in the third step. Subtracting 5 minus 4 is 1. Then step 4, bring down the 3. And now we go back to the first step again. 2 will go into 13 how many times? 6. 6 times 2 is 12. Now we're on step 3. Subtract. 13 minus 12 is 1, and we're at step 4, bring down the 4. 2 will go into 14 how many times? 7. 7 times 2 is 14. Subtract. 14 minus 14 is 0. Now bring down the 7. 2 will go into 7 how many times? 3 and a half. Beautiful. So, let's finish it. 3, let's finish it. So 3 times 2 is what? 6. And now what step am I on?
You add the 6.
Yeah, I just multiplied. So where am I?
Subtract.
Subtract. 7 minus 6 is 1. This part's important. You don't know it.
Bring down the 0.
I'm interested in fractions only today.
Oh.
So no 0.0. Instead, what is the remainder?
1.
Divide the remainder by this number, and that's your remainder in a fraction.
Wait, what did you just do? Oh, I got you.
So I took the remainder, right, which is equivalent to 0.5, right? So if you were to put this in your calculator, you would probably get this. But see, we can't express variables as anything other than a fraction, so we have to know how. All right? So don't gloss over and be like, oh, this is something we're doing. It's important. All right? For now, anyway. All right, let's do 2x squared plus 12x plus 11 divided by x plus 5. So this is one of the ways we can write that, but if I'm preparing to do long division, I need to write it like this. This will be x plus 5. And this will be 2x squared plus 12x plus 11. All right. And once you kind of set up here, I'm going to do it, and I'm going to do it relatively quickly. And then I'm going to go back, and I'm going to explain it step by step. So if you would like to just watch while I do it and see if you can follow what I'm doing instead of looking and writing and looking and writing, please feel free to do that, okay? So the first thing I'm going to do is I'm going to divide the first thing into the first thing, and then this is my scratch work. And so I'm gonna put that here. And again, I'm gonna explain why I do that later. So 2x times x is 2x squared. 2x times 5 is 10x. Subtract. 12x minus 10x is 2x. And I'm gonna bring this down. This is plus 11. All right, let's go again. I'm now going to divide the first thing into the first thing again. So this is my scratch work for that. 2x divided by x. It's just going to leave me with 2. So this is going here. Now I'm going to multiply. But this has two parts, so I'll distribute. 2 times x is 2x. 2 times 5 is 10. Subtract. 11 minus 10 is 1. There's nothing left to bring down. So this is the remainder, 1 divided by the original divisor. So let me talk to you about what I did and why I did it. And I do these little underlines because it helps me keep up. I like to do my scratch work to the side because it prevents unnecessary detail errors, right? So the first thing I did is I'm only looking at this. You'll hear me say the first into the first term into the first term. That's my red scratch word. How many times does x divide into 2x squared? Well, 2x times. Does that make sense? Right, so if I divide those two things, 2x is what it is. Okay. Why did I place it in this location? Well, I'm matching up like terms. Because it's linear, it's a single x, so it's going to go on top of the other single x. Okay. So now it's time to divide it. That's the first step. Remember, divide. Then we multiply. We're going to multiply this times all of this. And in order to do that, we have to do it by each thing. 2x times x is 2x squared. 2x times 5 is plus 10x. Okay? Then the next step after multiplication, I wrote it in a list. We will subtract, but we subtract the whole thing. So it's minus this and this. They both get a minus sign. Okay? And then this is 0. 12x minus 10x is 2x. Okay, so that is the subtract step. Remember, my last step is to bring down, and the next thing in line is the 11. Now I have a new starting point. That's what the green is for. Now I'm going to start over. I go back to the top of the list and I divide the first into the first. What is 2x divided by x? Well, that's just 2. That goes here because a number goes on top of another number. This is an organization thing. I divided. Now I will multiply. 2 times x, 2x. 2 times 5, 10. Subtract, subtract. That's 0. That's 1. There's nothing left to do. So 1 is my remainder, so I will add it. And remember, like I showed you with the 1 divided by the 2. Remainder divided by this is the proper remainder, and this is what you call your quotient. It goes on the bottom. Yep. Her question was whatever is on the outside, the divisor, remainder divided by divisor is the full remainder. And we write this as a fraction. And this is the process. It has little hiccups and bumps and little things that you have to know and work out. But overall, that is the process that you follow. And if you follow those steps, that's why I do it with numbers. It's divide, multiply, subtract, bring down, and then start up. This is really more than anything an exercise in being able to organize your work well, because you know how to do all the little parts and pieces, but there are lots of little details. So let me go again. Example number 2. Then I'm going to let you try one in just a second. But I want you to, actually, I'm going to let you try one right now. Oh, I know. Yeah, here's one. X minus 1. I'm going to write some steps up here for you. Actually, let me move this down a bit. It's going to run into that. You try and see how far you get. Example 2, x minus 1. I want you to divide that into 12x to the third minus 2x squared minus 20x plus 17. So remember, divide, multiply, subtract, bring down. And then repeat. Because what will happen is you'll start this process and then somewhere you're going to get stuck. And then I'm going to do it for you and you're going to be like, ah, and then next time you'll get a little less stuck. And a little less stuck. And then we'll be working through whole division problems. I'll write up here what you should be getting. Just so you can make sure you're on the right track. And then I'll do it for you. Yes.
Isn't there like a rule with like negatives? When you're doing it, or you have to change the signs?
When you subtract, you have to subtract the entire resulting expression. So you distribute that negative and everything gets a negative.
So change the sign.
Yes, and because if it's already a negative, the newly introduced subtraction will be minus a negative, which will be a plus.
So how do I change the sign? You have like a negative, or would you have just normal base there?
It's 10.
So you have like a negative 12x here, but that would change the
Correct.
right?
Oh,
Because the application of a negative to something that's already negative would make it positive.
I just remember because like I used to have a lot and when I did this to change the signs because it was easy.
Everybody forgets. Everybody forgets that, even me. I do it a lot.
I was trying to think, what could I use this for?
All right, I'm gonna start just silently working this out up here. So those of you that are still not stuck, and then I can keep going. This thing will work. Minus 10 would be 7. Let me talk you through this one.
Yeah, it's kind of tedious.
We're gonna do one that's kind of junky and messy up a little bit. Yes.
For the registers, I think the remainder of X plus one. And outside of X minus one. At the top is red. When you first it's 8 red. Yeah, it's plus one. So it's 7 over X plus one.
Oh, that's just miswrote it. That's not all. That's nice. Good question.
Some questions.
Yeah, because this is always gonna be this. Alright, so walk the other questions through here. How far did you get? Red, blue, and green.
Black. Yeah.
Got black. Nice. So you want me to do another one?
Yes.
I'm gonna do one that has a hole in it. And when I say a hole in it, it's because if you don't have 3, 2, 1, 0 powers on your variables, you have to insert a placeholder.
No,
Do you remember this?
I think you input a 0.
I remember this, I just don't remember how.
Yeah. Yeah, I think that's not the copy. It's 0. Yeah. No,
Because we're not
that's not
subtracting
what
all the time.
it
The original was, see how my minus is red and I went back and added.
It's just the fact that
That's all. Yep. And so if you ever get something that's like growing bigger instead of getting smaller and getting, it should get less complicated, not more. So if you have like a 30x there, you didn't change your signs. Okay. All right, let me fix this like stupid mistake I did up here real quick.
yeah, that confused me a little.
I'm sorry. I'm sorry.
It's okay.
All right, let's go again. Let me find just a gnarly one. Let's just do a gross one.
Yeah.
Where's one with a hole in it? Oop, I got one. Let's go again. X plus, I'm gonna do the same thing. I'm gonna let you try. Actually, let me write the original problem. Don't erase what you got. Don't erase what you got. I just want to show you something. Let's say I give it to you like this.
Mhm.
I mean, the first thing is, this one is what's on the outside because it's divided by, right? But do you remember I said that they have to be 3, 2, 1, 0? What power is missing?
The X squared,
Yeah.
there's always a 1.
0.
It's a 0. I was close.
You were, because you were thinking of the,
X on it.
that this is a multiplicative inverse issue and it's an additive inverse. So we don't want to change anything. One doesn't change anything we multiply, but we want, if we're adding and subtracting, we won't want to add anything, but your idea is correct. So what I want here is I'm actually going to write this when I rewrite the problem as plus 0 x squared, because that wouldn't change anything, right? One would, it would add an x squared term that actually is there. So blah, 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 blah. So let's just so we actually, what we're looking at is this. And so we'll do x, let me do this in black. So y'all try. Because zeros are just numbers, then nothing different is happening after the placeholder is added. So x cubed. Don't be afraid of it just because it looks different, because we know what to do. Just because it looks different doesn't mean it acts different. The process is exactly the same. Divide, multiply, subtract, bring down. And then you go back. So I'll do it while you do it. If you don't want to look up here, don't. easy, but. Gross. My arithmetic is super weak today. Or geometry kids this morning, they were like, yeah, I did subtract this morning. I watched the rest of Moon Knight last night, way later than I should have. And today, so was the placeholder a big issue or?
No.
Nah, it's like, don't forget it, okay? Your two biggest problems here are gonna be that you're gonna forget to put this in, and you're gonna mess up the signs on the way down, you're gonna forget to flip flop them.
I keep on getting confused because the signs, like I didn't do it right, but the signs, like I keep on switching.
Like, I get it all written, and I switch. All at the same time. So watch, you see how like my sign changes are in a different color? Like this is positive and this is positive, and then I just go back and go boop, boop. And like here, this is minus and this is minus, I just go back and go doop, doop. So I have, like, there are so many steps that I forget where I am. And the only way to fix that is just to do it until your brain figures out, and then your brain wants to tell you to do it. Mine does it right after I draw this line to subtract. My brain's like, that looks like a minus sign, so it's time to change everything. So that's how I remember. Your process is going to be yours. Okay. Is that all new? I know there's another page to this. Yeah. Okay. Long division. Let's see what else I can find for you to do. Oh, look. I'm going to show you something. Are you ready? All right. This is going to be great. I'm super excited. I am just super pumped about this. Let's go back up. Let's go back up to example number 1. Let me show you something. So I'm just going to rewrite this problem a little lower, and maybe you want to do the same thing, but we're going to do something else to it. This is example 1 again. So let's say, you're like, man, I really would love to divide this. I give you this, and you're like, oh no, I don't like doing this. And I'm like, that's cool, because we're just going to do this.
Oh, that's what we did in the small first.
Yeah.
That made it
That
so
was
much
the easiest one. I love
easier.
that one.
So this is,
What just happened?
I know, your
And then
brain.
you just do x squared and then.
All right, so that's what I got originally, right? Which one do you like better?
The box.
Yes, this is called synthetic division.
There's like a requirement for this.
There is a specific requirement, but I will talk to you about that in just a second. Let me talk to you about what I did first. So, yeah.
Broke down.
Yeah, so,
And you took up the point and took that negative 5. Then you took the negative 10 away from 12. Got that 2, multiplied negative 5 times that 2. And the negative 10 away from 11.
Yeah,
You got that 1.
You multiply
all right, I'm going to show you.
And the original
All right.
equation.
Let me show you where I got all of these things, because this is going to be in practice what you do when you can use it. So you have to know 2 things: how to use it and when it is appropriate to use. So the first thing is this. Turn into this. What is the, if I were to set this equal to 0 and find the root associated with this factor, which that's what it
X
is.
equals negative 5.
Right, so x is going to equal -5. So in practice, it's swapping the sign. What it's actually doing is taking the root and not the factor. Are you following me? No? Yeah, kinda. Okay. Set it equal to 0, and that goes here instead. Can you just swap the sign? Sure. You need to know where it comes from eventually. So I just swapped the sign of this piece. And then I drew this upside down box, and these numbers are the coefficients of what is here. 2, 12, 11.
And you always bring the first one down.
And you always begin the process by bringing down the first one here. You do nothing. You bring it down. And then you multiply. -5 times 2 is -10. So subtracting, we add. 12 plus -10 is 2. And then multiply again. -5 times 2 is again -10. Add. 11 plus -10 is 1. That's how I get here. These are the coefficients of what remains, or the quotient, after I divide this polynomial by this one. Because I divided, really what I'm doing when I'm dividing, FYI, is I'm factoring out. When I get this, I'm factoring out this from this. Factoring out is basically dividing. Okay? So what's left is exactly 1 degree lower. This is a degree what? 2. So I should begin with degree 1. So this would be 2x. And then the next degree down is no x, so that's just plus 2. Plus 1, and the last one's my remainder, 1 over the original divisor.
I was wondering, I remembered it being so much easier last year.
But the rules are, this must be a linear binomial factor. And what I mean by that is there can be no coefficient here. And it's gotta just be x plus a number or x minus a number. If you have an x squared, if you have a 2x, this does not, you must use long division. You have to work it all the way out. But if you're working with this is game every single time. Let's do the other two examples.
Yeah,
Could you
can we-
change it?
Hmm?
Could you change, like if there was a problem that did have a coefficient or an exponent, you can't like.
You can't change the factor.
Can we do a problem like that in class work it out?
Yes. Go back and do example 2 like that, see if you get the same thing. Right. Just do example number 2, that's what I'm gonna do, is I'm gonna do example 2 again
Yeah.
to illustrate. You don't remember this, or you do?
I do remember it. I just been a long time.
It has been a long time, I agree. Let's see. Example 2 was this one, okay. Example 2 was 12x cubed. All right, see what you can do with that one. And then, if you want to also give example 3 a try. Example 3 again, a try. Dang, which one did I do for I skipped on example 3. Yeah, definitely give example 3 a try because it's got that hole in it. And that's what you're going to forget tomorrow on the quiz. Is how to deal with those holes. So try those, and then I got like maybe a couple more things to show you. Yeah, I mean, I really only have like 2 more examples to show you after this. After you get this down, the 2 slightly different applications of this idea. Because I'd rather you have plenty of time to work on it in here so that we can kind of hash out all the issues. Because this is just a tool we're going to use to graph polynomials. So we're about to go back to graphing again. And in order to successfully graph these higher order polynomials like degree 5, degree 6, You have to learn how to do this so you can factor those things. Ooh. Factoring is coming back. Oh god, it's terrible. My stupid line is so crooked. Let's see.
Oh, I'm just stupid.
Same, girl, same. Deeply in my soul, I am also stupid sometimes. 10. Yay. And look, you can just get a preview of how lazy I am. I'll just do this. Sure. Oh, you're right.
Just -2 plus 12 is 10, so minus 10 is.
Your numbers start getting really big, you're probably messing up. What is it?
Not true.
That's good. What I got the last time?
His last video was all the way too. I believe it was that much. It starts obviously, but like with him. Yeah. I'm pretty sure I took AP with him.
All right, I'm gonna do one more example. How are we doing with this? We good?
Yeah.
All right, good. I need you to do this one. I need you to do this one. 3x to the third plus 19x squared plus 8x plus 12 divided by, it's going to seem very much the same, but there's something special I have to show you. There we go. We'll do it together if you want. Do it and see what happens. It's the remainder. 0. This tells you something important.
Tells me that there's no remainder.
There, right? But what can you infer from that? You can say that, remember I told you that this is essentially factoring. So this tells me that x plus 6 is a factor of 3x to the cube plus 19x squared plus 8x plus 12. And when something is a factor of something, it evenly divides into it, right?
Yeah.
There's no fractional remainder, it evenly divides it. And so when you have a remainder of 0, like if you divide 3 into 6, there is no remainder, so 3 divides evenly into 6. 3 is also a factor of 6, would you agree?
Yes.
Okay. So this idea, we're just extending it into complex territory. So this is something you will need to know tomorrow. I will ask you, is this a factor of this? And you will do what?
Prove it.
How?
By doing synthetic division
And
or
getting a remainder of
Zero.
All right, if you get a remainder other than 0, you will say, no, it's not a factor of that. And if you do, you will say, yes, it is a factor. So the first step, and this is not something you need to know, but a preview of something you will need to know. I can write this. This is the first step of factoring this third degree polynomial that cannot be factored by grouping. This is its factor form. See it? This factor times what's left, right? Okay. That's important, or will be later. I'm going to show you one more thing. I want you to, you know what evaluate means?
Evaluate.
Work it as far as you can.
Work it as far as you can. So evaluate. No, stupid computer. Oh, let's see. Evaluate f of x equals 2x to the fourth power plus x to the third power minus 3x squared minus 6x minus 1 at x equals, I changed it. At x equals, which one did I do?
3.
Minus,
Don't you just plug it in?
yeah, you can. Yeah, just plug it in. Evaluate. What'd you get?
3.
Did you plug it in? I did it faster than you did.
Wait, what?
Are you gonna-
I'm still confused about where you get
Again,
the
I did this last year.
numbers, like force division.
Okay.
This is the coefficient.
The coefficients. Oh, 2, 1, -3, -6, -7. So part of the remainder theorem, you can, like Kennedy said, she said, you know, the way you originally learned to do this is to plug in -1 everywhere there's an x, but that's kind of a pain. But the remainder theorem says that I can do it with this process, and the remainder is the function evaluated at this value.
So we can do it.
You have to do it like this for me tomorrow, using the remainder theorem. So you can, like,
And then we can just check it by.
oh yeah, you can check it by plugging it in. But I need you to know that you can evaluate using this process. Do you see what I did? Is like I'm still amazed that it works. I'm like blown away that that's true. So tomorrow, I will say to you, evaluate this using the remainder theorem. And the remainder theorem just says that when I perform synthetic division in this way, the remainder is equivalent to evaluating the function at that value. So you will need to show me this to answer my question, okay? If you don't show me this, I will count no credit for you. You can check your work by plugging in like you used to, but I need you to know that you can do it this way. Ask me some questions.
Like, I have one. Why is it the remainder and not like another? Like, why is it the remainder?
I do not have an explanation for you past that it is a theorem that I know to be true. If you would like me to research it further and report
Hey,
back to you,
it's a good.
I will gladly do that. But somebody told me this and I was just like, sounds cool.
Sounds good to me.
Right, I mean, I'm actually curious. I think I looked it up last year, I don't remember, like why it works. I'll bore you with it tomorrow, because now I'm curious.
It's gonna be ethics quiz, right? So the quiz is gonna have.
Maybe I'll just post a YouTube video, and if you're curious, you can go look at it.
And that would be nice.
Yeah.
Wait, is it quiz tomorrow? Y'all are talking about the homework check?
Is it this?
Oh,
This
it's
and
actually.
So don't, okay,
It's
so
this
the
and the stuff we
difference,
did Friday, right?
Hmm?
This and the stuff we did Friday. So like Pascal's formulas.
so let me talk to you for just a second. Shh, let me talk to you. I'm gonna give you the